Alright, now half-life. Half-life works similar to double time. Again, if you've taken any type of, especially chemistry or biology, they typically use half-lives. That's how we date things. And if you're talking about radioactive decay, almost always they give you the half-life of anything that's radioactive. Alright, so again, it's literal. The time it takes for half the quantity to be left, again, over a given time period. So my example from before, suppose that after, oops, I have hours, this should be years. After 5 years, again, I'm going in half the amount. So suppose in 5 years, I started out with 1,000, it declined down to 500, right? 500 would be half of 1,000. So 5 years is its half-life, right? Another 5 years, 10 years after the initial amount, you take the 500 and divide it in half. That amount would be 250. In another 5 years, 15 years after the initial amount, you take the 250 and divide it in half, and that comes out to 125. So in 15 years, if our half-life is 5 years, that means 3 times it was divided in half. It breaks down to, or what's left is only 125. And again, it would continue. Another 5 years, you would take that number and divide it in half, and so on. And so the equation that we get for half-life in an exponential formula, so this is exponential decay, is the following. And again, it's very, very similar to the double time with one big difference. And again, it's a very important difference. So we'll suppose h is the number, so that's the number of times we have it, right? So if we get 4 half-lives, 3 half-lives, 10 half-lives. The amount of substance remaining, so the amount remaining is the initial amount times 1/2 raised to the half-life. Alright, and so the difference is, the half-life actually has the same meaning as the double time. It's the how far into the future you want to go divided by the half-life. The difference is you divide by 2, right? When we did it before, we doubled, so we took it times 2. When we're halving, it should make sense that it's a divide by 2, or a half. We have a half-life in there, so again, it's a half. So it's our initial amount times 1/2 raised to the number of halving times. The number of halving times is how far you want to go into the future, so this would be your time given, divided by your half-life. Alright, so to do the example that I gave you above, suppose that you started out with 1,000, alright, and our half-life was, remember, 5 years. Every 5 years it divided in half. So the initial amount is 1,000, so Q naught is 1,000. H would be our time divided by 5. That's what H would be. Right, time in years divided by 5, because our half-life is in years. So again, check the answer that we got earlier for 15 years. So our half-life would be 15 divided by 5. So again, 3. It divided in half 3 times. 3 times we cut it in half. So our quantity equals 1,000, 1/2 raised to the 3, or again, if you wanted to, you could do 15 over 5 instead of 3. It should give you the same thing that we found earlier, which is there's 125 of whatever it is left, right? In 15 years. If you go look at when I cut it in half 3 times, right? Ended up in 15 years, we ended up with 125 if we started out with 1,000 and our half-life was 5 years. 3 times it got cut in half. So that's what that H means. That H means that's how many times it gets cut in half. Just like that D represented every time it doubled. So suppose we go another 5 years, right? So this would be 20 divided by 3, 20 divided by 5, which means 4 times now we're going to divide it in half. So our quantity 1,000 times 1/2, but 4 times we're going to divide it in half. And so it should make sense. It's actually our previous answer, 125 divided again. But if you multiply it out in the equation, again, it should be the same exact thing. And it is. It comes out 62 and a half. All right, 62 and a half. All right, next example. So we're going to do a couple of examples for half-life, because like I said, half-life is the one, if you've ever taken a science class, this is almost always the one they talk about. All right, so anything that's radioactive typically has a half-life that's known. All right, so suppose for a certain radioactive substance, the half-life is 610 years. Right, so that's how long it takes for whatever this radioactive substance to decay. Alright, so there's initially 30 pounds. Find the formula for the exponential function that gives the amount of rating after h half-lives. Alright, so quantity equals our initial amount, which was, again, that's our initial amount. It's a half-life, so it's 1/2 raised to the h. Remember, h equals our time. In this case, it would be years into the future, divided by 610. Alright, so how much remains after 976 years? Well, again, there's a few ways you can do this. If you want to, you could use 1/2 time over 610, which means that's the t. T equals 976, or you can figure out how many half-lives there are there. So take 976 divided by 610, which comes out to 1.6. Exactly, again, never round. It came out exactly 1.6, so I can use 1.6. If this didn't come out nicely, which actually was my next example, you would have to leave it exactly the same fraction. Alright, so our future amount is 30 times 1/2 raised to the 1.6. Or again, like I said, you could have used this fraction. Gives you the same answer either way. Means I should have less than what I started with. Again, another clue that you've done it right is that you should get less than what you've started with. It comes out 9.896, so I'm just going to round to 9.9 pounds left. Alright, how much will be left in 1,000? This isn't much different than the 9,706, so it shouldn't be much different than my previous answer. And again, the reason why I did this one, because I'm going to show you, you do not want to round. This one does not come out nice. This one, if you take your 1,013 divided by 610, it comes out 1.6606. So again, it's a non-repeating, non-terminating decimal. Leave this exact as is. Do not round until the end of the problem. So when you type this out in the calculator, make sure you practice it. It's 1/2 raised to that fraction. Do not round until you type it out. So I have parentheses around this. You need to make sure you put parentheses around that because that goes all up into. So it's 1/2 parentheses raised to parentheses 1,013 divided by 610. It comes out to 4 point. So I'm going to round to 9.5 pounds. Right. And again, it's not much different because not that many years passed between these two. It takes 610 years for it to be cut in half. This is only about 40 years. So again, it doesn't decay very much in 40 years. So it should make sense that those two numbers are fairly close. The biggest thing about this one is do not round until you get to the end. Alright, stop there. We'll pick up the remaining section, or the remaining set of notes in the next video lesson.